right. Hi, everyone. Thanks for sticking around for my talk today. SPOTcon seems like it's been awesome. And I am here to talk about feedback loops and how we can use them to shorten the path to production through observability. But first, we always got to start with a little bit of background. Hi, I'm Christine. I am a developer. I also happen to be one of the co-founders of Honeycomb, which is less relevant for this talk. Really, the only piece that's important here is that I care so much about this topic that I stopped writing code to help other people write better code. The way that I started writing code, probably like many of you, except I did it with PHP, print statements, right? This is how you made sure that your code was working. You would sprinkle these around your code to check, is this variable what I think it is? Is this branch of logic being hit the way that I think it is? And especially in the beginning, once I was like, cool, like the print statements are coming out, I was like, cool, my code works. I'm done. Everything is perfect. Mostly worked. I don't know, worked enough in the beginning. Learning JavaScript, being able to use the developer tools and browsers was a revelation. Being able to manipulate live variables to, again, make sure, okay, what is the variable here? What's going on? Is this, did I manipulate this in the way that I expect? Awesome change. As I got into the workforce, I learned to embrace tests, right? Cool, test-driven development. Think ahead of time of all the weird test cases or all the weird edge cases that your code might hit. Make sure the code handles it okay. I was fresh out of school, and like this like worked really well with my brain to try to comprehensively predict all the ways that all the ways that my code might misbehave and like enshrine it as a test case. It also worked well with the sort of hubris one needs to believe that that's possible. That one can anticipate all the ways that things will go wrong, but new grad, fresh in the workforce, that's how it goes. I even got used to using an exception tracker, which I was told was necessary now that I was working on a real life code base with real users. This arbitrary screenshot of my my email inbox may be familiar to some of you. And to be fair, these emails and stack traces being pushed to me of what was actually happening with my code in production was useful-ish, because with the stack trace, I could go look up it, map an exception to the actual line of code where it was being thrown. I could try to repro it. There were two sort of shortcomings here. One, the user had to run into the exception in prod in the first place, and there's no guarantee I handled the exception well. So who knows, might have been a terrible experience for a user. And the second thing was not every exception was exceptional, right? Something like a statement invalid, like maybe that was a mistake, or maybe that was just, thrown for some other reason. And not everything interesting was an exception. And the volume of these emails got to the point where I, as an early developer, would be like, okay, well, once tests pass and I merge my code, I don't need to pay attention unless I get an email about the code, and then I'll go back and look at it. Which, again, works if you believe that this stream of exception emails is like all that you need to know about your code. There's even an anti-pattern where some folks on the team would throw exceptions for things that weren't a problem because they knew that it would get caught, but they wanted that email to come into the inbox, which kind of works, but starts to be, bumping up against the edges of what these exception trackers were used for. So if you look at these sort of this progression, there's a theme here of what I and the folks on my team were looking for with these approaches. Some sort of feedback, some sort of signal of, did the code I write behave the way that I expect now that it was in the wild? Did the logic flow the way that it was meant to, the way that it did in my head when it first sprang into being? Because we all need this feedback. You cannot anticipate all issues that might come up with your code. And you need the feedback because even if you come up with a weird edge case, maybe it shouldn't be immortalized. I always like to start off talk by being like, this is my bias. And all the things that led me to this point have taught me that tests are great. Writing tests and TDD and all these practices are great, but they're not enough, because when you like code, when you write a test, it's a snapshot of what is in your brain, what you expect that code to do when you write the test. And that test suite is run continuously while the code changes. So who keeps the test suite updated as the mental model changes? And how do you make sure that your mental model is changing over time? Well, anyway, you can imagine where the punchline of this is going. I always have to pause because, again, as a developer, when I first started hearing about monitoring and APM tools, at least, I was like, this is something for the DevOps folks and the operations folks and the people who are carrying the pager. I'm just a developer. I write code. And first, I think those boundaries have blurred in the many years since I was a baby dev. But there's a couple other reasons I really like to talk about observability as a developer to developers. First, when we're writing tests, right, we are constantly comparing what we expect versus what the code actually spits out. And that's basically what all of these tools are trying to do in production. You're looking at a graph and you're like, I expect it to be mostly flat and stable, and then it's not. And you're like, okay, well, now I need to go figure something out. And I like this language of expected versus actual because it's a mindset that reflects the reality that you can write the most beautiful code in the world, but all that really matters is whether it does the right thing for the people who are trying to use it. And whether you're writing tests or looking at graphs of production data, when you start there of what is the code supposed to do and move inward, you're able to spend your time and focus on the things that actually matter. A note, when I talk about observability, I think of it as being sort of distinct from traditional monitoring or traditional APM tools, mostly in that when I see sort of this difference in graphs, I expect to be able to ask why. When a graph I see doesn't look like what I expect, I want to dig into it. I want to figure out why a subset of this graph is deviating from the norm. What's special about those points so that I can reproduce it, maybe write a test, maybe say I don't need a test because this is actually just like, my buddy over there doing weird things. But the ability to dive in and ask questions, that's, I think, something that is unique about where the observability conversation is going. And observability is distinct from pre-production tests in many ways, but most notably, maybe, in that it serves a slightly different purpose. With tests, when expected deviates from actual, it's a failure, and you get your build turns red, and you get emails, and sometimes it can be very embarrassing for you if emails go out to your whole team. With observability, with these graphs about production, if a graph starts deviating from what you expect, it's almost more of a, how interesting, what's going on, why is this happening, do I want this to be happening, or is this something I need to go and stop? Because again, the goal here is feedback loops, right? We're trying to solve the same problem that we used to with these printfs on our local machines. With these inputs, do we get these outputs? And the difference is with observability, these tools that are looking at your production code, you're able to capture that difference under conditions you don't actually control yourself. Running code on your local machine, very different from, I'm going to put this out here and let the World Wide Web mess around with it. And that's all it is about. There's lots of fancy terms that tend to be thrown around in the same space as observability. Some rightfully so, some just because they're correlated. But that's like these things, types of data, that's not the purpose of observability. That's not why this matters. It's all about the simple question, what is my code doing? Because maybe I'm hearing from users that it's not doing what I expect, and I'm chasing down support tickets, and I'm like, oh no, someone's really upset. Maybe you're looking at some top-level measurement Maybe you've been tracking overall latency, or you care a lot about, maybe your boss cares a lot about sort of overall volume of requests handled, or ticket sales, and that top line number isn't what you expect. In the end, it's what's my software doing, and is it doing what I expect it to? And I'm just going to hammer this point in one more time. Observability is something you layer on top of tests, because even though they're different entry points, the workflow is so similar, right? You have a signal, test fails, or someone complains. Step one, confirm that what's going on is what is actually happening, that the test isn't flaky, or that the user's Wi-Fi is turned on. Step two, you're isolating the issue. Okay, is all of my code broken somehow, or is it only part of the code under certain conditions? Step three, repro. Maybe you're capturing as a test. Maybe you're putting it as you want to capture it as something that will be immortalized in your test suite. But I love this layering because of the parallels, right? With test coverage, you're trying to make sure, well, in both of these cases, you're trying to think ahead of what will matter. What should I be anticipating? You're thinking through all the use cases. Great. When you build a test plan or an observability plan, which I think people talk about less, but people should be doing, how will I know that my code is working? Right? How will I know that it is continuing to be correct even when I can't be running it on my computer watching it? The same sort of things that you think about when you're building testable systems, modularity, abstractions, all of that applies also when you're thinking about observable systems. Where are my boundaries? How does this logic contained? This is maybe an example of it not working, just words are hard. I'm going to move on. In the end, this question of how is my code doing, for whom does it suck, or for who will it suck, is all about being able to handle this myriad of different conditions and the myriad of weird ways that your code might operate differently than you expect, and learning from it and being able to write better code going forward. Ultimately, observability is what will provide the truth about what your users, your systems, your code is doing, but then when you're not able to watch it. At its simplest, right? The development process can look a little bit like this. And this is when everything goes perfectly. You just come up with an idea, you write the code, you write a test to make sure it does what you think it does. And then you're like, okay, go be out in the wild, go do your thing. Also at its simplest, when things go wrong, it can look a little bit like this. And let's call this the reactive, or the oh no, I broke it scenario, right? Why does this happen? Even in the systems with the most robust, most thoughtful, most well-written tests. Well, we're all building systems that are online. We're building systems that are complex, have multiple components. And the more complex we make something, the more true it is that there's an infinitely long list of black swan failure scenarios of that 1 in a million combination of something that you couldn't have predicted. Imagine building say you're building a mobile backend as a service at scale, and you've got X API endpoints and Y SDK platforms that you're supporting, and then Z number of SDK versions that you have released, and then you have then a number of app versions and B number of operating system versions, and you take X times Y times Z times A times B, and you can't possibly write that many test cases pre-production. You just have this constantly exploding set of combinations that maybe your code will behave, maybe it won't. And external APIs make it worse. The more, these days, very few services are entirely self-contained. You're calling an authentication API or a payments API, great. But again, when you expect your code to behave a certain way and you have this external dependency that you can't look into, you are then incorporating their infinitely long list of potential failure scenarios into your world. Why else do these things break? Well, when you're looking at data at scale, when you're trying to figure out why, trying to make sure your code works for hundreds, thousands, millions, billions of users or customers, that noise can drown out the signal. Imagine having, again, some sort of platform where you have a tiny customer with a completely broken experience and a big customer with, just spewing HTTP 200s, like totally going fine. It can be really hard to know which things to write test cases for, what conditions cause your code to misbehave. But the thing is, if you're constantly existing only in this "oh no, I broke it" mindset, look how long this loop is from the time you think of writing some code, the time it starts misbehaving, and having to go back and fix it then. In the meantime of this, like while this loop is, progressing across the slide, there's an impact on other users. The context that was in your brain when you thought about this is gone. You can, again, write a test to capture that one tiny customer situation, but then what about the rest of that infinite list? What about the next tiny customer that you didn't anticipate? And so one of the things that's interesting to think about is how can we shorten this loop? How can we make it so that we have more context in our brain, fewer folks are impacted, and we can get ahead of an issue before it impacts customers? Well, what if instead of putting the observe step at the end of this, where only after the code is pushed to production do we start to think about, well, okay, now let's make sure it's behaving out there. What if we took a lesson from that TDD mindset that I described, where you're constantly writing tests and using that to check your code? Is there a parallel where we incorporate that production check step earlier and earlier in our process? Again, instead of the "oh no, I broke it," what if we start to ask ourselves, let's check if it worked, so that we shift it one step earlier, like during that test period of like confirming that the code that I wrote is behaving at least right in front of me. Can we check production? Here, test in production is a phrase that can actually mean many different things. Can also apply to feature flags. But it's a chance to experiment and hypothesize and check those experiments, check those hypotheses in production on code while it's not fully baked. There's no down here. Sometimes performance improvements are a great example of trying to achieve some result. And many of us have spent a lot of time trying to make staging very similar to production, so that when we see a performance improvement on staging, we can feel confident that it will mirror the performance improvement we want to push to production. Staging will never be production. There are some systems that are impossible to really model. And sometimes figuring out a way to contain an experiment and check it in production is really the only way forward. The clue. Hope all of you, many of you, caught Alicia's talk earlier. Feature flags are great. This is a way that you can constrain that experiment. There are others, but being able to target and measure the impact of some change that you make on a specific subset of traffic, very cool. And I'll point out one more thing that, again, I think was a question I always had as a developer that wasn't always in the mind of the ops folks I would work with. Is my code even what's running, right? If I'm trying to check if my code works in production, are there signals that will confirm to me that the version of code that's in my IDE that I'm staring at is what users are experiencing live? Sometimes yes, sometimes no. Different build, different commit in a build, particular feature flag on or off. To make this more concrete, I have a story from my friends over at CarWow. Pedro and his team had a hypothesis for what was going on behind a poorly performing API endpoint, but it only performed poorly sometimes. They're like, what's going on? So the team made a small change to test their fix in a small way on a small slice of inputs that they hypothesized triggered the bad behavior. And they were able to use data about what was actually happening in production to confirm that, yes, great, the change that we made resulted in improved performance. They were then able to roll the fix out widely. Once they'd convinced themselves, they'd tested, is this actually the result? And then they were able to drop the 99th percentile latency by 2 orders of magnitude. Very cool. Because responsible engineers are looking for feedback loops in their work already. And good tooling that flexes to whatever analysis they were doing, can shorten those loops even more to make sure that engineering teams never go too far off course. They don't do the whole rigmarole release process for something that was 2 clicks off base. What if we go even shorter though? What if we pull that production check, not just for, okay, let's make sure that what I wrote works, but instead, how should I write this code in the first place? And what I mean by that is, when you're writing code, right? One of the things that you're trying to figure out in the first place is what is normal? What are the cases I need to handle? Who's depending on the existing behavior? All the time, you hear engineers be like, "Oh, well, we don't really need to handle that that case because no one really does that." Okay, do you know that for sure? Can you check it? If you're assuming that some API parameter or flag is not set a certain way, can you confirm that with data? And again, I keep beating on this performance drum, but it is easy to get caught up constantly trying to squeeze out some performance improvements in your IDE, in your test environment. And good performance matters. How much does it matter? Who will be impacted? Being able to validate hypotheses in production. I'm going to tell another story from our friends over at GeckoBoard. I think of it as you're really trying to figure out how bad is the situation really, right? I think something is going on. I want to spend some time stabilizing this part of the system. Being able to look at production, conjure up like real graphs in real time, and confirm that, oh yeah, like the latency spikes that someone has been complaining about are actually correlated with processes crashing and coming back online. Great. Now you have a much clearer understanding of how to go about the code, performance optimizations or code you're about to write, to make sure that you're fixing only what actually needs to get fixed. But we can go even earlier than that, right? We can go even before you're like, oh, well, I want to do this thing, to help you figure out where to spend your time in the first place. I like this pain language, because it's something that only you, the developer, only your team, only your company are going to be able to really describe. What does pain mean? You want your users to have a better experience. What does better mean? When you can quantify the pain, and maybe it's slow endpoints, maybe it's error rates, maybe it's something else, but being able to take that, go look at production, and use that to prioritize your time, your team's time, means no one's wasting cycles doing something that doesn't matter. And with that prioritization, knowing what step number 2 is, step number 3 is, you can imagine doing some sort of migration where starting at the simplest endpoint, not the most painful, but it's the easiest place to get started, and going one at a time. Being able to, having that muscle of checking production helps you know what's next, how much more is left. Another performance example here, performance regressions, right? That one of the hardest problems in software is everything is getting a little slower over time. Uh, in the test-only world, or the pre-production test world, a pattern I have done is really trying hard to capture performance regressions in tests. It's kind of useful, assuming your CI system never changes and nothing is ever flaky in the shared environment where you're running your test suite over and over and over again with the same inputs. Much more interesting to be looking for performance regressions in production, because that's what your users are actually experiencing. And this translation layer, like getting good at figuring out what impact looks like, mapping that to your code, that's the superpower. It's really common to do things like, oh, well, show me the slowest database transactions in my application. Okay, here are the slowest. Does it matter if the slowest one was only run once? What if you imagine, instead of looking at the slowest, or translate it to some query language, the max duration of database transactions, what if you translate that to the sum of duration spent? Where is my database actually spending time? Okay, well, if half the database's time is being taken up by this one query, if we make that query faster, boy, that'll have a lot more impact than just making that slowest database transaction faster. You can take it a step further, translate it to beyond end user experience to your business. Okay, well, maybe you care about improving a bottleneck for the highest number of users across the system as possible. You can take some duration, but then group it by which database transactions are impacting the most users. When you can start to draw this line, have this short, describe what matters to you as you write code in your business in language that your observability tool can use, then you can start to short circuit these feedback loops even before you write the code to make sure you're spending it on the right things. In the end, these feedback loops are meant to help us increase certainty in the time that we're spending writing code. We all want to write code that matters, that does something, that is used. And by having more of these short feedback loops, we can get there. Last piece. This wouldn't be a good talk unless I left you with a little bit of like, okay, how do I get there? I want to talk a little bit about instrumentation. Instrumentation is just the inputs into any observability tool. It is how the code describes itself back to you. And I think we should treat instrumentation like docs and tests. And I know I was just talking about how tests are snapshots and they don't change, but there's an element of keeping them alive. You don't want to, also an element of, you can't boil the ocean. You're not going to try to go from 0% to 100% of test coverage in a day. Many would argue 100% test coverage isn't even the ideal. We don't try to do that with instrumentation. But by thinking of it as just part of how we ensure that the code we write is good, we make sure that when we need it to, the code can tell us what's going on. Also, like tests, the easier that we make it for ourselves to write and update instrumentation, the more likely it is that we will do that. Something to keep in mind. Two things on instrumentation. One, I think it's really important to make sure that your code talks back to you in language that makes it easy to map back to your business logic. I feel like with the monitoring world, certainly my experience with ops people in the past, old school ops people, is that when they come to me and they say things like, hey, Christine, this graph, you said that you pushed a change and now my Mongo's throughput has 3x'd. I don't know how to map that back to my business logic. I don't know how to map that back to my tests in my world. So make sure that the instrumentation that is being fed into these tools that are supposed to talk about production and the impact on users is stuff that you'd put into your test cases. Identifiers, parameters, inputs, things that will help you as the developer figure out what conditions are special about a user hitting an edge case. And then also stuff that helps you and your boss understand that impact that I described, right? Hey, it's a lot easier to be like, I cut latency in half for our biggest customers on our most expensive endpoint. That's a whole lot better than, again, I made Mongo throughput twice as efficient, period. Why? Why does that matter? And second thing about instrumentation, talking back to you in a language that makes it easy to map back to your code, the code itself, not just things that matter in the code. But this is I'm squeezing this in. I think we'll see a little bit more of that in the next session. Tracing as a visualization type, as a data type, is incredible for making sure that you can see the branch of logic that a user hit. By being able to see sort of the execution laid out like this, it helps close that loop, it helps developers make sense of your code, what's happening. Sort of as a non sequitur, I know I've been talking about production this whole time. Tests can also emit traces. Observability actually isn't only constrained to production. It's just a way, again, to check actual versus expected. If you haven't yet, play with traces in your tests. One more on the how we build these feedback loops, how we make use of the data. If we're going to be using this instrumentation in production often, we should make sure that it is easy and fast to do so. Log lines, printfs, console.logs are all useful and great for humans to read and engage with, for someone learning how to code, to confirm that they are causing this line to appear. But most of the software that we're operating live today is operating at scale. And that code isn't running at human scale anymore. It's running at machine scale. And so searching through logs for lines that humans can read with our eyeballs isn't going to be enough. What we need to figure out how to zoom out. If we're looking at our software from the outside in, making sure that the behavior is right, we should start using this data by learning to look for patterns and trends, looking for outliers against the norm, not trying to match individual log lines. Modern observability tools are really good at this sort of analysis, and we humans should take advantage of that to put machines to work for us in order to help us humans understand what matters. And the final piece is a little bit of, we got to learn from each other, as in code review, as in when we're talking about test failures. Maybe there's an opportunity here for both actively learning from each other. Hey, can you walk me through the choice that you made here, or can we talk about why you architected it this way? There's also an opportunity for passive knowledge transfer with observability in these feedback loops. There's an opportunity to say, oh man, how did you, let me go see how Jessica investigated an issue yesterday. That's how we translate what's in someone else's head, which might sound like gibberish when we first hear it, to muscle memory, to things that we as developers can do regularly and use to shorten these feedback loops and understand production. So this is the summary slide. This is what I want you all to think about. Observability is just like testing, expected versus actual, but really, really useful in production. Observability plus testing layered on top of each other. That's where the gold is. Sometimes things are failures. Sometimes things are interesting. And the whole goal here is shortening that feedback loop between, I think I wrote this code, and this is what the code is doing. Because ultimately, you want your code to be able to describe itself back to you, what it's doing all the time, so that you can learn and write better code tomorrow. And that's the end.